Hey everybody, today's lesson is going to be on the intermediate value theorem, which states that I can prove values exist between closed intervals. Here's Kermit the Frog with our example.
We take you now to Kermit the Frog with another fast-breaking news story.
I'm so excited about this.
Hi, this is Kermit the Frog, and I am standing outside of the Super Game Stadium where today's Super Game is about to be played. And these people that you are seeing that are standing behind me are waiting in line to watch this fantastic game. And I thought I would speak to a couple of them now, and I will. Just watch me. Here I go. Excuse me, ma'am.
Yes?
Pardon me, I was wondering, I'm Kermit the Frog of Sesame Street News.
Oh, yes.
Yes, well, I was wondering if you could tell me what is it like to be the last person in line for this game?
Oh, am I last?
Yes, ma'am, you are.
Oh, well, you must understand, you see. It was a terrible morning.
Terrible morning,
The car broke down, I couldn't get a babysitter.
Right, that sounds pretty boring, ma'am.
Wait a moment.
What?
You are standing behind me.
What?
So that means you, Frog, are last.
No. You see, I'm just standing here talking to people.
No, don't worry. I'm sure you'll get a seat, even though you are last.
No, I am not last.
You look last to me.
Well, moving right along, folks. Moving right along. Let's just step up to the head of the line here, and we'll talk to the person who is first in line. Pardon me, sir. What is it like to be first in this line?
Well, he's not first. Actually, I am.
What do you mean you're first? I'm standing here, aren't I?
Well, yes, but you see, I was first. I just stepped back to speak to my friend here.
Well, actually, dear, I think the frog is first.
No. I'm from Sesame Street.
Well, it doesn't matter where you're from. You're first.
I thought I was first.
No, the frog's first.
What's going on?
No, I do not want to be first.
Well, it doesn't matter.
All right, gates open, everybody.
All right, excuse me.
Ouch. Frog, don't worry. Even though you are last, I'll save you a seat.
Thank you, Kermit, for that example. Okay, so here's our problem. The number of people waiting in line for the big game is modeled by the continuous function L at t for 0, which is less than or equal to t, which is less than or equal to 7. The values of L at t at various times t are shown in the table, which is right here. For 0, which is less than or equal to t, which is less than or equal to 7, what is the fewest number of times at which L at t equals 50? Give a reason for your answer. So here at the table, we have our hours go from 0 to 7, and the number of people who are in line from 0 to 7 hours, okay? So the question is asking us to find out how many times, or what is the fewest number of times that it equaled 50. So let's look. 25 to 37, 37 to 84, 84 to 97, 97 to 121, 121 to 46. So think about it. How many times in this table did it reach 50? So if you guys were thinking about it, it reached it twice. It went to 50 during 37 to 84, and from 121 to 46. Do you see? It goes from 37 to 84, passes 50, and from 121 to 46, it also passes 50. Okay, so our answer would therefore be 2, and to explain, IVT, which is the intermediate value theorem.